Good evening and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This evening we'll be looking at exponential graphs, their properties and how to sketch them. So the first thing I've done is I've drawn out the exponential graph y equals e to the x, the exponential function. Very briefly, just why is it called the exponential function? Well, the reason it's called the exponential function is it's constantly increasing, but at any point on the curve, if you were to draw a tangent to that curve, the gradient of that tangent would be the same as the y-coordinate. So the reason it's called the exponential function is actually if you differentiate e to the x, you also get e to the x. It's pretty smart. General features of this curve, its shape looks like this. It has a y-intercept of 0, 1, which should make sense because if x is 0, e, which is a number, anything to the power of 0 is 1, so we have a y-intercept of 0, 1. And we also have an asymptote here at y equals 0. And the reason we have an asymptote is this is a value the function cannot take. Because if you have a number and you raise it to a power, you will never get 0. It gets closer and closer and closer to 0, but it will never get there. Hence this asymptote. And what I want to explore in the first part of this lesson is what happens to the shape of the curve when we have constants involved. So we're going to look ultimately at the equation y equals ae to the power of bx plus c, where a, b and c are all constants, they're all numbers, and we're going to look at what those numbers do to the curve. Now the best thing to do at this point would be, if you've got a graphical calculator or you can download the app called Desmos, would be to explore this yourself by changing these values a, b and c. But don't just stick in random numbers for a, b and c, because you'll see the curve changing but you won't be able to see why or understand the pattern. So break it down and do it systematically. Begin by just changing a and see what that does to the curve. Then look at just changing b, and finally look at just changing c. So if you want to do that, pause the video and have a play around, see if you can work out what's happening. If not, that's what I'm moving on to straight away. So what you will have found is that the value of a is stretching the graph in the y direction. So it is a y stretch by factor a. So what that's doing is it's multiplying all the y coordinates by a, and it's making the curve steeper. So on this curve here, what you should have spotted is rather than having a y-intercept of 0, 1, it's going to have a y-intercept of 0, a. Because that 1, that y-coordinate, has been multiplied by whatever number you made a. Now the asymptote won't have changed. The asymptote will still be y equals 0. Technically you're multiplying everything to do with y by a. If you multiply 0 by a, it's still 0. Now if you change the value of b, you may have struggled to see what the difference was actually, because what that's doing is it's stretching it in by, it's an x stretch by a factor of 1 over b. So if you made b 2, it would be squashing it in by scale factor a half, like so. So actually the intercept won't have changed, it will still be 0, 1. You still have y equals 0, but what you would find is you would have the shape of the graph would actually be getting squashed in, so it would look something perhaps like that if you change the value of b. Finally, changing the value of c, what that's going to do is it's going to move the curve up or down in the y direction. So it's a y translation by c units. And what you'll have noticed is that will have moved the intercept up by c units. So the intercept is now 0, 1 plus c. And because it's moving everything to do with y up by c, the asymptote has now become y equals c. So that's given us an idea of what each of these transformations will do to the original y equals e to the x curve. What I'll do in the next video is we'll start with an equation where we have values here, and I'll talk about strategies we can use to sketch that curve. I'll see you then.